So this is the solution for an RC circuit with a switch in it. And this is problem 5.41 from the ULB book. So remember, you're going to do 4 different circuits to find the values that you need for that general form equation. So again, the general form equation is going to be x of t is the final value plus the initial minus final quantity, e to the minus t over tau, and with tau we're with an RC, so it's going to be RTH times c. So the first step is to do before a change happens, and in this case this is going to close at time equals 0. So before the switch changes, it's going to be open. So we're going to leave this section open, and then the capacitor has sat there a long time, meaning that it's going to be also an open. And we want to find the voltage across the capacitor, the plus to minus. So with this, we can then analyze this with node voltage, with ground on this side, and our node on this side. So the equation is going to be VC minus 16 over 2K plus VC over 2K plus 4K equals 0, and get a common denominator. Or we don't even have to do a common denominator, just 1 over 6K equals 16 over 2K, and then we can divide this by 1 over 2K plus 1 over 6K. And this value ends up equaling 12 volts. So at the switch change, which is right at the time which we denote as just 0 plus, plus meaning the change time, this then becomes a closed circuit, and this becomes a voltage source of a value from that step that we just did, so 12 volts. And that's the value we're trying to find, so this time frame is our initial value. So this will be, at this time is our initial value. Then we need to find at the final value. And so in the final state, this is closed, and this is still going to be open because it's sat there for a long time. And again, the voltage across this, so we have VC minus 16 over 2K. And now that wire is in parallel with the 2K, so it's just going to be VC over 4K equals 0. And there's no current in this branch. So now solving this, we get 1 over 2K plus 1 over 4K is equal to 16 over 2K. And then we can divide by this, and this gives us a VC value, this one, and this gives a final value of 10.67 volts. So the last step is to find tau. And so to find tau, we need to we take out the element, and we do it at that final stage. So the final stage is going to have this as a wire, which means this is still going to be ignored. And then we are going to remove the voltage source, which means this becomes also a wire. And so our pathway is split, so we have an RTH is 2K in parallel with 4K, which ends up giving me a 4/3 K. And tau is just that times is RTH times C, and in this case, C is given as 25 micro, which is 10 to the minus 6. And so this ends up giving me 0.033 seconds. And my final equation then is going to be VC of t is equal to 10.67 plus 12 minus 10.67 e to the minus t over this 0.033 seconds. And this will be valid for all time greater than 0. So for t greater than or equal to 0. And so this is my final expression. Thank you for watching.